another problem. So, pabigat ng pabigat. Siyempre, ilatag na natin sa inyo yung mga mahihirap. No, para pahirapan natin ang mga sarili natin. So, for number 3, determine the magnitude of the horizontal and vertical components of the total force per meter length acting on 3/4 cylinder gate shown. Nanghihina ako. Sakit sa ulo nito. Hindi, kaya nyo yan. Okay, so as you can see, the gate here is a 3/4 cylinder. Ibig sabihin, kunti na lang kuta sa isang buong circle na siya. So, 3/4 lang yan. From A to B. So, ang shape niya pa ganun. Ang hahanapin natin is the total horizontal and vertical components of that. Okay? At least, magnitude lang yung hinahanap. Kailangan pa ba ng location? Ay, hindi. In fairness, okay? So, syempre, ang kailangan natin munang gawin is unawain kung paano ang approach dito sa problem na to. So, as you can see, this is a 3/4 cylinder. Pag ganon. So, kung ito yung tubig ba to? Oo, water. So, the liquid here is water. Liquid is water. Ayan, na may mga isda. Ang tendency ng kanyang hydrostatic force or pressure na muna. So, ang tendency ng hydrostatic pressure is syempre mag-act siya along the perimeter of this tri-quarter or 3/4 cylinder. So, drawing ko siya, no? Ito yung pressure na mararamdaman nitong quarter circle na ito. Ganyan. Palibot. Siyempre, syung, ganun. So, kung may container ka, kung container mo itong bilog, nandito yan. Palibot. Ganon. Ibig sabihin, magkakaibang direction siya. No? Sanay kasi tayo doon sa isang hydrostatic pressure na, alam pa ganito, kung incline. So, ang hydrostatic pressure mo dyan is acting along perpendicular to the ganyan. Kung ito ay plane surface. Pero kung curved surface, so it is acting along the perimeter. So, ganyan. Tapos, kaya nga tayo kumukuha ng isang resultant na horizontal saka ng vertical to represent all of the direction of that one. Gets? Kaya meron tayong isang FB, meron din tayong isang FH. Yun. Paano yan? Kung ganito ang direction. May napapansin kayo sa tendency nung kanyang pressure? 'Di ba? Ang pressure mo from A dito sa kalahati ng A is facing the left side of the 3/4 cylinder. While dito sa malapit sa B, ang pressure direction is towards B. Gets? So, hiwalay. Ganun. So, humihiwalay yung kanyang direction in terms of A, papunta dito lahat ng kanyang pressure, tapos B, papunta naman here. Ibig sabihin, makakakuha tayo ng resultant na force na contradicting. So, pwede ko siyang hatiin into two shapes. Meaning, this semicircle A, let's put another point, letter C, no? So, A and C to B. C to B. Yan. Para bongga. Ibig sabihin, ang lahat ng force acting on AC is acting syempre towards the curve AC. Papunta dito. The direction naman ng horizontal is acting towards the gate. So, Fx. Ibig sabihin, magkakaroon ka ng dalawang value of Fx. We have here Fx2 and Fx1 acting to the right and to the left. Pag ganon and pag ganon. sa makatuwid, igagawin natin siyang parang composite figure ulit. Meron tayong semicircle, meron tayong isang quarter circle, tapos pag pinag-add mo yun na yung magnitude of the horizontal and vertical component. Okay? So, isa-isahin natin siya. Isa-isahin natin ngayon yung horizontal na muna tayo, ano? So, we have here A to C. Yan sabi ko. Plus DB to C. So, we have here B to C to B. So, yan yung kabuuan ng ating kabuuan ng 3/4 cylinder, no? So, hinati ko siya sa dalawa para ma-dissect nga natin siya. So, we have here a horizontal force X1 tapos contradicting horizontal force 2. So, the total Fx here is equal to Fx1 minus Fx2. Why? Because we have here a horizontal force for facing to the left, and then we have here a horizontal force facing to the right. So ang kukunin mong resultant syempre is the difference between Fx1 and Fx2. So kung alin dyan yung mas matimbang, nandun yung location ng resultant. Pero since importante sa atin ang sign kung saan papunta yung direction, so mahalaga na kunin natin siya as difference. So i-take natin as positive force yung papunta sa left. So, assuming that. Okay? So, we have here Fx is equal to gamma h bar A. That is forever and always the formula for the horizontal force. So, gamma h bar A. Paano natin malalaman? For Fx1, sige na, for Fx1, dito na lang, that is 9.81 ang ating unit weight. H bar 1 is the location of the centroid of this semicircle with respect to the water surface. So, sa makatuwid, the height here is equal to ito, 2 meter plus ito, 2 meter ulit, no? Paano? Diba, ang location ng center of a circle projected vertically is just equal to the from the radius to the origin. So, kung ano yung height mo yan na din yun. Yan yung kagandahan ng semicircle at ng circle. So, from the origin to the radius, yun na yung height. So, 4 meters. And what is the area? The area you will consider here is the projected vertical area of this figure. So, let me show you 3D ulit. Ito 3D ko yan. Sandali. Ayan na. Naka 3D na tayo ulit. So, from the figure, as you can see, ganito nga yung kanyang shape, no? So, 3/4 cylinder. Ayan. So, sa makatuwid, ganyan halos ang itsura mo. So, itong kulay blue is the water. Tapos, itong nakikita nyong bilog na yan na medyo 3/4 is yung gate. So, ang mag-aak na barrier niya ay talagang yun. And, kaya siya tinawag na cylinder kasi nga meron siyang per meter length. So, 1 meter length is that. Di ganyan ang itsura niyan. So, ang magre-resist nitong hydrostatic force is yung kurbada mo dyan. No? At kung titingnan mo siya on the front view, so front view ganyan. Side view, so tingnan natin side view, iikot-ikutin ko siya. So, sa side view, ayan, as you can see, that is parang rectangular lang ang kanyang projection. Kahit may kurba siya. So, rectangle. And then, pag-iikot ko ulit din sa kabilang side. So, ayan na, circular. So, kung titingnan mo yan dyan sa looban yan, so, sandali, i-dissect ko itong So, ito kasing kabuuan ng water, no? So, kung kukunin natin yung side up, hanggang dyan. So, ang kanyang projection is just rectangular along the side view. Pero kung titingnan mo siya sa front view, ayan. Yan yung tinutukoy ko. Okay, so, projection yan from side view to front view. Kahit nga top view niya, no, pwede mong kunin. So, maganda na meron tayong illustration of the 3D of the figure para at least malinaw, okay? Kaya tayo kumukuha ng rectangular equivalent na area. Kasi yung projection niya from the side, kung titingnan mo, kahit curved yan, or ayan o, kahit curved yan, diba? Lapat naman na rectangle siya. Okay, therefore, the area that we will consider here is the vertical projection of the side view, meaning that is height times length. Ano yung height niya? Nabanggit na ang radius is 2 meter. So, therefore, the diameter ang ating i-consider. So, 2 plus 2, that is 4 meters. Height pa lang yan. Ano yung kanyang length? So, the length is, I will draw a isometric, So, ito yung length niya. Yung pinakita ko sa inyo. Itong length. Tinuro ko. Ito yung length niya. Yan. Tapos, ito yung diameter. Siya. And what is that? Ang sabi naman kasi dito, per meter length. So, when we say per meter length, so per 1 meter, yun na yun. So, kumbaga, ang length mo dyan lagi is 1 meter. Saka na lang siya isa-substitute into a longer version. Kumbaga, kumukuha ka lang ng strip na merong 1 metro. Kasi mas divisible ang isang bagay kapag pine-per meter mo na lang. So, 1 meter length is the length of this to be considered. Okay? So, we have 4 by 1. That is 4 square meters. Then, di meron na tayong gamma h bar a ng fx1. Wala pa tayo ng fx2. Okay, wait lang. Saan ko isusulat? Dito na lang rin. So, fx2. Ito namang fx2, we will consider the right version. No, so meron tayong gamma. Gamma is still naman water. Kasi nag-act naman yun all throughout this circle. And then, magkakaiba lang siya ng area, syempre, saka ng height. Ang area mo dyan is the area of the quarter circle projected here. Here to here. So, tingnan natin ulit nga. Balikan natin yung figure. So, ito yung area 1. Ang area 2 mo is move ko lang. Ayan, na-reverse na. So, ayan, kukunin ko yung pinaka-gitna. Ayan, gitna ba yan? I think. So, when you project it as if ito lang yung i-consider mo na so, kung titingnan mo siya sa side view, tagalin ko to, yan. So, kung titingnan mo siya sa side view, yan lang, yan. Yang area na yan. From here to here, ang ating ipoproject. And ano yung itsura niyan? Tingnan mo nga dito, oh. Ayan. Kung titingnan mo siya sa ilalim na part, ang area niyan is just also rectangular. Ayan. Ito lang. Dito lang kayo mag-focus. Yan. Sa pinibilugan ko, no? So, ganun yon. Di balik ako dito. Ang area niyan is simply radius. Kasi ito yung radius niya, diba? So, that is radius multiplied by the per meter length na 1 meter. So, 2 meters by 1 meter. And what is the projected vertical height of the liquid surface to the center? That is equal to, ayan, as you can see, yung total nito is 4 meters. So, from liquid to the gate, 4 meters, plus yung kalahati ng centroid na projected ng rectangle as is. Okay? So, malinaw man ano, ito lang din yan, kukunin mo dyan na CG. CG2 up here is equal to kalahati naman ng radius. So, sulat ko lang, 4 meter yung height nito, ito to here, plus yung radius. So, 2 over 2. Ayan. So, meron na tayong unit weight, area, and height. Kulang na lang summation of forces. So, pag nagsa-summation na tayo ng resultant force F, that is equal to Fx1, sorry. So, Fx is Fx1 plus or minus. Magandang tanong. Is it a plus or a minus? We are, syempre, considering the sign convention always on the direction of the force. So, if Fx1 is acting to the left of the curve, and Fx2 is facing the right direction, therefore, hindi siya pareho ng direction. Ibig sabihin, contradicting. Ibig sabihin, difference. No? So, magkaiba yan kasi papunta dito, papunta dito. Hindi mo siya pwedeng ipag-add para ka nag-take na pareho silang to the right direction or to the left. Pero since to the left, everything you own in the box to the left, so minus yung kabila. Siya. Taking forces, summation, so we have the gamma HA, 9.81, H bar is 4, while simplified na to ha, H1 is 2 plus 4 over 2, so ilan to? This is 2 meter plus 2 meter, that is 4, minus 9.81 by what is your height? Height is 4 plus 2 over 2, and what is 2 over 2? That is 1 meter, therefore, the height is 5 meters by the area. What is the area? 2 by 1. So, simply that is 2 square meters. And solving for the horizontal component of this hydrostatic force, we have 9. Let me dictate 9.81 by 4 minus 9.81 by 5 multiplied by 2. Final answer is, I hope you're getting my answer too, that is 58.86 kilonewton. Ganyan lang kadali ang horizontal. Para ka rin naman nagpe-plane surface kasi projected vertically lang naman yung mga force. No? So, 58.86. Let's see the malinis na solution. Ayun. So, the value of FH is 9.81 by 3 by 2 is equal to 58.86 kilonewton. Therefore, nabigyan kong hustisya yung ating sagot. Ito, let me just read siguro the solution. This problem falls to number 3, where the condition number 3, where the fluid is above and below the curve. So, ayan. Anyway, yung fluid naman niya is acting on this one. So, kaya tayo kumuha ng dalawang composite figures. We have the semicircle plus the quarter circle to get the final resultant force. Yan. And then, ito, hinimay-himay niya lang naman dito yung H1, H2. Tapos yung area, tinotal na niya. So, ibig sabihin, 4 by 1 minus 2 by 1. So, kaya naging 2 square meter. Parang ganun rin naman yung ginawa natin, di ba? Oh. And, yan, per meter would be considered L is equal to 1 meter. So, pag binanggit yung per meter, alam niyo na. That is 1 meter. Okay, so tapos tayo sa hydrostatic force na horizontal. So tapos na tayo kay horizontal, no? Proceed tayo kay vertical na vertical components of the total force. Okay, so ang principle ni FV is to multiply the unit weight by the volume of the liquid above or below the liquid, the curved surface. So, ulitin kong unawain itong ating kurbadang ire. So, 'di ba? Naisulat ko na yung pressure diagram niyan. So, ang tendency ng pressure mo is act along the perimeter of this curved surface. So, ganyan, no? Tapos, di ba kanina sa horizontal, nagkaroon tayo ng dalawang action towards to the left tapos towards to the right. Kasi, as you can see, the direction of force here is different. So, meron ka ditong papunta rito, tapos meron din papunta rito. Ganon din parang halos, actually, ganon rin sa vertical. So, vertical, we are talking about the upward and the downward direction. So, kung hahatiin ko siya into 2, pag ganito naman, so try kong hatiin ng gantong sides. 'Di ba? As you can see, dito sa babang quadrant, ang direction ng force niya is pababa. And then sa up dito sa quarter na to, towards upward naman or pataas yung direction ng force. So, ibig sabihin, kung titingnan nyo, dito, ano na nga yung letter natin, nandun sa baba kanina yung C, no? So, gawin ko dito naman. So, C, and then this is your C2, letter B. So, as you can see, let's say, the resultant force of the vertical is acting towards this curve from this diagram, itong kalahating circle na yan. Tapos pagdating mo dito kay AC, ang vertical force naman niya is already acting upward. So pataas yan. So meron kang direction na pababa, meron kang ding direction na pataas. So okay lang na hatiin natin siya into 2 parts. Also, another pointer to consider is the location of the water surface. So water man na to, no? This is water surface. Tubig yan, may mga isda pa. So, point number 2, ganito. Tingnan mo, saan nagfo-fall ang condition nitong B to C natin. So, ito yung C. Saan nagfo-fall? Recall, the curve BC is below the liquid surface. So, ang liquid surface mo ay nandito. Ibig sabihin yung kurbada niya, napapatungan siya ng tubig, katubigan. Ito. 'Di ba? Whereas, kabaliktaran siya ni AC. How? Why did I say that? Because the curve AC, can you notice? AC ay nasa itaas ng tubig. No, yan. Ibig sabihin, itong C to B falls under case number 2. Recall na yung case number 2 is the liquid is below or napapatungan nung curve surface, and this A to C naman is your case number 1 where the curve is above the liquid surface. So, kung imagine niyo, andito yung tubig nung una, tapos pagdating mo dun sa pangalawa, ganon, pa-push. effort, pa-pushing upwards yung ating liquid dito sa A to C. So, anong implication yan? So, kung case number 1, tapos case number 2, therefore, that falls under the category of case number 3. Di ba? Sabi ko sa inyo, combination ng 1 at 2, case number 3 yun. Pero ano gagawin natin kapag ganyan, kapag case number 3? Simply, yung kanya magiging area dyan of concern, magkakaroon ka dyan ng mga plus minus, always. Kasi nga, di ba, mag-opposite direction of vertical force, meaning, kukunin mo yung resultant yan, so kung ano yung manaig, plus or minus. So, simulan na natin siyang i-project yung kanyang areas. Ayun, case number 1 is fluid is above the curved surface, and then case is below. So, the fluid is above the curved surface for case number 1. So, case number 1, fluid is above the curved surface. So, ito yun, no? So kung ito si C to B, the fluid is above. Yan. And then for case number 2, the fluid is below. Yan. So from A to C. Generally, kung ako ang pag-iisipin, ang hahanapin ko lang dyan na volume ay itong volume ng quarter circle nito. No? Ay, plus ito pa pala, sorry. So, ito, yan yun. Plus ito. So, technically, kukunin ko lang talaga yung total volume niyan. Yan, yung parang medyas. Mukhang medyas na yan. Yan ang total hydrostatic force talaga, generally. Pero, dahil nga tayo ay case sensitive, we have to abide by the law. So, meaning, kapag kinuha ko yung vertical projection nitong C to B, wait, sige. So, from C to B, ito yon, no? Yan, ito. Tapos, kapag minus ko siya, minus the vertical projection above case 2, so ito, minus ito, diba? Nagets niyo yung idea? Wait na lang. Doblehin ko tong ditong figure. So, ganito. Kapag i-minus itong kabuuan nitong AB, no? So, A to B. Yan. Ito yan. Say, for example, yan nga. So, i-isolate ko. Kung ganito yung itsura ng A to B, minusan ko siya nitong imaginary liquid above A, A to C. So, minus daw nitong A to C. So, anong natira mo? Diba yung medyas? So, logically, ganun yung idea niya. No, i-minus rin naman natin siya i-minus rin naman natin siya eventually. So, ang matitira mo talagang area is the area of this medyas. Pero again, dahil nga tayo ay case sensitive, meaning, tayo ay mga law-abiding citizen. So, kailangan nating panindigan itong case number 1 and then case number 2. Kasi, hindi naman sa lahat ng pagkakataon madaling mahanap yung area nito. 'Di ba? So, we have to follow the rule of making the condition, susundin natin yung condition na yun. Okay? So, pwede ko na bang sabihin na itong area 1 natin, tapos ito yung area 2. So, to get the FV, we have to know FB is equal to gamma V, right? Where gamma is automatically 9.81 kilonewton per cubic meter. So, that is the unit weight of the water. And then, to get the volume now is equal to the length per meter length multiplied by A1 minus A2. Isa-isahin natin ngayon yung area 1 saka yung area 2. Okay? So, can we do A1 first para masaya? So, yung A1 kasi falls under category number 1. So, kung ito yung C mo, tas ito yung B, you will project the liquid above the curved surface. Yeah, yan, ganyan. So, kung ito yung total niya, ito yung, di ba, ito yung 4 meter. So, under this, rectangle, this is also 4 meters. And then, your total width is 2 to 2. So, since radius mo is 2 meter, diameter total is 4 meters, right? So, tapos, pagdating mo dito, this is also 2. and then this is 2, and then this is 2. So, meron kang dalawang composite na area of the rectangle, and then area of the semicircle. So, to get that, syempre, we have to get the area of the rectangle plus area of the circle. Ayan. And ano yung rectangle? So, from the figure, sundan nyo na lang po. The area of rectangle is equal to, tama, 4 by 4. So, 4 by 4 meter plus the area of a semicircle. So, hindi pala siya circle. So, kalahati lang. Para cute. Ayan, kalahati. Ganun, no? O, diba? Cute. Kalahating circle is pi r squared over 2, no? So, pi by 2 squared over 2. And that is the area number 1. Siya, ano ba yun? Ano yung area 1? 4 by 4. 4 by 4 plus pi by 2 squared over 2. So, the total is 22.28. So, I will save this. 22.28 square meters for area 1. So, si area 1 kasi, pre-project ko siya yung kanyang liquid. 'Di ba? Sabi ko sa case number 1, kapag magkakaroon ka ng projection, ipo-project mo yan lahat. Itong area niyan. Yan. So, ito na yun. Nakuha na natin. Tapos, pagdating mo sa area 2, dahil yung liquid ng water is below this curved surface, so nandito yung water, so area of water, force of water. So ang kailangan mong gawin dyan is to project an imaginary liquid above the the curve. You have to project an imaginary volume of liquid above it to counterpart. Diba? Parang yun yung weight na imaginary. So, sabi ko nung unang slide, imaginary weight yan. So, paano natin kukunin yan? Paano ang puso ko? Char. So, para din siyang, tingnan mo, rectangle. So, rectangle, pwede ko ba sabihin na area of a rectangle? So, area 2 is area of a rectangle minus area of a quarter circle. Yan. Where the area ng rectangle mo is this part, so 2 meters. 2 meters by the height is 4 meters minus the anong area ng quarter circle? That is 1/4 pi r squared. So, 2 yung radius. So, makukuha na natin agad na yung area 2 is 2 by 4 minus pi over 4 by 2 squared. And the answer is 4.85 or 86. 4.86 square meters. So, save ko siya sa ayan. Ayan. So, therefore, to get the total area, we have to minus A1 minus we have to subtract A1 from A2. So, A1 is, 22.28 minus 4.86 is equal to, ilan yun? So, alpha A minus alpha B. Ayan, 17.43 or 424 square meters. Now, to get the volume, we have to multiply area by the length. And ano na nga yun sabing length dito? Ayan, per meter length na. So, kung sinabing per meter, that is already 1 meter length. So, 1 meter. The total volume now is 17.424 cubic meter. Now, to get the vertical component of this, vertical component of the hydrostatic force. So, 9.81 gamma V, gamma V, 9.81 by 17.424, and the final answer should be by 9.81. 170.94 kilo. tama, 170.94. So, ganito ang ruling. Kapag ang ating liquid is nasa taas or napapatungan nitong ano, so ang kukunin mo dyan, syempre, is the volume of that. Pero kapag ang liquid is above, I mean, if the liquid is below, meaning wala dito sa taas niya yung liquid na andito sa baba, magpo-project ka dyan ng imaginary weight. Okay? So lahat kasi nung naging example natin kanina pa from number 2 to number 1. Ayan oh, napapansin nyo. Lahat yan falls under category number 1. Oh, where the curve is below. Ayan, so below siya lagi nitong water surface and also yung number 1. So ito naman, ito madaling makita kasi yung number 1 niya pa ganito. So yung liquid mo is below ulit, so nandito. I mean, yung liquid mo is above ulit, so yung below mo is yung curved surface. 'Di ba nakakalito? Kapag nasa ibabaw ng curve yung tubig or liquid, so it falls under category number 1 or case number 1. Pero in case of yung kanina na nga, where this is your liquid, gulo. So, ito yung liquid mo. So, magpo-project ka dyan ng imaginary weight. Ganun lang yung ruling lagi. So, para di kayo malito, may isa pang example.